This is geometry lesson 9.3. We are now looking at pyramids and cones. So very similar to the cylinders and the prisms that we looked at in 9.2. Pyramids and cones are two special types of conic surfaces. Okay, so we all know what a pyramid looks like and what a cone looks like in general. So this should make a lot of sense. So we are going to call these types of solids conic solids when they come to a point like this. And when we talk about the boundary of it, the outside, not talking about what's on the inside of it, but just the outside, what makes it up, like if it was a cardboard box, that is called a conic surface. So again, we use that word surface. So the biggest part of this section is just basically knowing the vocabulary of what means what here. The big word that we're going to talk about is the apex. So that's going to be the top where this all connects, the point at the top. And of course, we're going to have a base. So in our prisms and our cylinders, we had two bases, one at the top, one at the bottom. In a cone and pyramid, we have one, and then it comes to an apex on the other side. The conic solid is the set of points between the base. So notice this is kind of a goofy looking base, right? It's not a polygon, but it doesn't have to be one of these conic surfaces. But we're only going to really be looking at the ones that are pyramids and cones. All right, so we have the base and then the set of points that's between the base and the apex. So a pyramid is the surface of a conic solid whose base is any polygonal region. So it can be a square, but it could be a pentagon, it could be an octagon, it can be a triangle. Okay, and that creates these pyramids. And then a cone is going to be the same idea, but the base is a circle. All right, so the parts of the pyramid that are named at the figure at the right. So of course we've got the apex at the top. All of the lines that go from the vertices of whatever polygon is at the bottom that goes up to the apex. Those are going to be called our lateral edges. So we've talked about lateral faces of our prisms. This is the same idea. Even though we're not going base to base, we're going base to apex. So these are going to be our lateral faces, the actual triangles that are formed here. And the sides of those triangles, where this would be um, like kind of the connection, the edge, where you could feel the edge if you were going to run your finger over that. That's called our lateral edge. All of this space out here is the lateral. Of course, at the bottom, those would be called your base edges. So basically, where these faces connect are still called our edges. It's either the base edge or the lateral edge. We classify these by their bases, just like prisms. So we're going to call these either a triangular prism, a square prism, pentagonal, pyramid. I said prism, pyramids. So it's all just based on the bottom. So what we're looking at here, we have a five-sided base. This would be a pentagonal pyramid because the base is a pentagon. And just like prisms, we can have a right pyramid or we can have an oblique pyramid, depending on if the apex to the base hits at 90 degrees or if it kind of leans sideways. That would be our oblique pyramid. So a regular pyramid, again, just like with our prisms, is any right pyramid whose base is a regular polygon. So we could have a pentagon down here that's all different size angles and sides. So that would just be a pentagonal pyramid. But if you see the word regular pyramid, we know that it's a regular polygon. And eventually we're going to get into certain times where we're going to have to find the area of that. And we know how to find the area of a regular pentagon. So question number one, draw an oblique square pyramid, and then we're going to label some certain lateral edges. So let's start with just the basics here. If it's a square pyramid, that means the base of it is a square. So let's go ahead and draw a square. And if we're going to label it a square, we know all the sides are equal and we know all the angles are 90. And if this is going to be an oblique pyramid, it's not going to go straight up where from the apex down it would hit at 90 degrees. So we're going to go ahead and make this lean sideways. So let's just pick an apex that's out here somewhere. So it's going to make it lean a little bit. And we're just going to draw the lateral edge to each one of these. Now, normally if there's one that's kind of behind, so like this one will be behind, you would draw it with a dotted line, but for just our basics here, that's fine. We just want to make sure we understand the vocabulary here. So the square pyramid means the base is a square. Oblique means it doesn't go straight up 90 degrees. It's going to lean a little bit. And now we're going to label our lateral edges. So remember, the lateral edges are these lines here connecting the vertices to the apex. And if you notice, both of these have an S. That means S must be the apex. And then we could put the R down here, and we could put the T right here. So we have a lateral edge RS, and we have a lateral edge TS. You could go ahead and label the other sides if you wanted to, but we're going to leave it just like that for this question. All right, pretty straightforward. If you flip it over, cones, just like a pyramid, like we said, the difference is the base is a circle. We're still going to call the top the apex. These are going to have a special line that goes through the apex, down through the center of the circle. That's going to be called its axis. So you could draw this axis and you could spin this cone on that axis, and it would actually have rotational symmetry. Eventually we'll get into that. But you could spin it on that if you can just imagine that cone spinning around that axis. All right, so we covered axis there. When the axis does hit at 90 degrees and it's perpendicular, we call that a right cone. So that's kind of the cones we're used to seeing in everyday life. That would be a right cone where it just goes straight down 90 degrees. But of course, you could have one that instead of going straight out 90 degrees, it goes down on an angle. So if I connect the apex to the center of the circle, I would be creating an angle that's not 90 degrees. So that's an oblique cone. So the surface of a cone other than the base is the lateral surface. So we don't have like true lateral edges because we don't have the connection of sides here. But if we look at the cone from the side, just looking at it from the side view, the edge that we see here, even though it would be smooth because this is a cone, we wouldn't be able to feel that same edge like we would with the pyramid. That straight line that we would see from a side view would be called our lateral edge. And sometimes we're going to need that measurement there, so we will have to refer to that as the lateral edge there. So the entire outside is the lateral surface here, where you would hold if this was an ice cream cone. That's all going to be called the lateral surface. And then the lateral edge, again, is just the side view. It's not something that you could feel with your finger. All right, and then we're going to talk about some basic measurements and some things that we can find with these. Using those lateral edges, the axis, the apex. And eventually we're going to start finding some mathematical measurements in these with volume and surface area, and we'll have to use all of these different measurements, so we'll need to know this vocabulary. So that's why we're going over it. All right, so the altitude of a pyramid or cone, it's the height. That's going to be the line segment from the apex to the base that's perpendicular to the plane containing the base. So on your right pyramids and right cones, the altitude goes from the apex directly down. It will hit the middle of whatever the base is, and it'll hit it at 90 degrees. So that's always going to make sense to us that that's the height, right? But where this could get a little confusing, so if I draw a cone that leans sideways a little bit, and I'm going to try and draw this one correctly. So I'm going to have a circle here at the bottom. So the front of the circle I'm going to label like this. If you notice with this cone right here, the dotted line means you couldn't actually see it in real life, right? Because it's behind it. Okay, that's an oblique cone. We can label it. And the altitude here is not going to go from here to here. We never measure height on a diagonal. So to go back to the definition, it says it's the line segment from the apex, which is right here, to the base, perpendicular to the plane containing the base. So it doesn't actually have to hit the base. We don't have to go diagonal here and create an angle that's not 90. Altitude and height is always measured 90 degrees. So it's going to be from here straight down, and the angle that it's going to form there is your 90 degrees. So this can be your altitude out here, just like the height here is our altitude on the inside. So when they lean sideways, the altitude is measured on the outside. It's always straight down 90 degrees. Whenever we need that measurement, look for your 90. All right, we're still going to use the radius, just trying to make sure we cover all the vocabulary. We know what that is there. And then the last one we want to go over is slant height. Okay, so slant height is measured on the outside here. So each lateral face of a regular pyramid is an isosceles triangle. So all the faces here on a regular square pyramid are going to form these isosceles triangles. And then the lateral edge is actually the height of one of those triangles. Okay, so just kind of like when we were looking at finding the area of a regular polygon, we split it into triangles, and the height of those triangles was the apothem, right? It was a special measurement, but it was just the height of one of those split triangles. Same thing is going to be true here. Your slant height, you take one of the sides, the height of that, okay, is going to be your slant height there. Your slant height in a cone is this measurement on the outside, so it actually is your lateral edge on a right cone. And we will go ahead and use that sometimes when we are looking for volume and surface area. Okay, so question number 2, which is longer, the slant height or the height of a pyramid? So if we take a look at this picture, h is the height or the altitude, and the L, the script L there, that's your slant height, the measurement on the outside. What you'll notice, and you'll see this, is they're going to form right triangles, because in a regular pyramid, in a right pyramid, the height is going to come down and hit at 90 degrees, and then it's going to form this nice little right triangle. And we know when we have right triangles, if it happens to be a special 45-45 or 30-60, we know how to handle that. But just for everyday right triangles, we're always thinking Pythagorean theorem, because that works for every single one. So I kind of warned you in the last chapter, don't fall in love with the 30-60-90s. Don't assume everything's a 30-60-90. You can't do that. But you can always use Pythagorean theorem when you have a right triangle. So looking at that, the slant height is across from the 90. So that's the hypotenuse. We know that's the longest side of any triangle. So to answer this question, the slant height is longer than the height. Because it is the hypotenuse. Okay, it's across from the biggest angle, it's across from the 90. Therefore, the slant height must be bigger than one of the legs of that right triangle, so it is going to be longer than the height of the pyramid. All right, and real quick, what if we're given some measurements and we need to find something that's missing? Very straightforward. So we have a regular square pyramid. The height, AB, is 10. BC, they tell you, this bottom piece here, is 7. That would be the distance from the center to the outside. That's actually the apothem, right, if we were trying to find the area here. But in this case, we don't need to use it as that. And so we have two sides of this right triangle. We are missing the hypotenuse, which is the slant height, AC. So it's super easy to find. You're just going to drop right into a squared plus b squared equals c squared. Eventually, we're going to need these measurements to find either surface area or volume or something like that. And so we need to recognize that even if it's not given to us, if we have some of these measurements that form a right triangle, we can go right back to Pythagorean theorem. That's why we spent so much time reviewing that. And we can find those missing sides and then, of course, use them down the road. But today we're just looking at how do I find it if I need it. So we're going to drop everything in. These are your legs. Hypotenuse is your C, right? So we're missing C. The 10 and the 7 are going to drop in here. And we're just going to solve it out. So 10 squared is 100. 7 squared is 49. So that combines 149. You go ahead, you take the square root of that. And it's not a nice number. So depending on the problem, you may want to just take that decimal and round it. Otherwise, you're just going to leave it as the square root of 149. Depending on what the question is asking for you. So we'll, in this one, just kind of give both approximately 12.2. Once we get into some more specific measurements and things, the directions will tell you how to give your answer. We don't need to worry about that today. We just want to make sure we recognize these right triangles are being created with the altitude and the slant height, and we can use Pythagorean theorem to find something that's missing.